Hello everybody, good morning, good afternoon, good evening where you are. Thank you so much for joining us today for what is the last Nodes 2020 extended session. And we've got another 2 fabulous talks for you to enjoy. So, I am joined today with my colleague, Jesus Barasa. I had to. We have a talk on Neosemantics and I thought, who better to bring along? If we've got to talk about Neosemantics.
There was no one else, right?
The only, the one that only. So,
that's right.
Tell us a bit about Neosemantics. Tell us a bit about
yourself.
Sure.
Yeah. Well, thanks. First of all, thank you very much for inviting me, Lou. It's a pleasure. I mean, I'm really excited to hear about what our guests will be talking about today. But yes, just a couple of words on Neosemantics. So I've been leading the efforts on these projects. So Neosemantics is a labs initiative, is a labs project, which is this incubator that Lou's team is managing. That includes very popular extensions to Neo4j like APOC, the Kafka connector, GraphQL extensions. You probably can help me here, but there's a bunch of them. It includes Neosemantics. That's our plugin, our kind of toolkit to integrate with RDF and semantic technologies stack from Neo4j. So I've been leading that project for the last few years, and that means writing some code, writing some blog posts, some examples, and basically interacting with the community, with teams like the ones you're going to be hearing from today. And well, the latest is we're doing great. I mean, the community is growing. I mean, this week we've hit the 20,000 mark in downloads. So there's clearly some interest there. There's a community growing. There's lots of conversations in the community portal. We're just about to release a 4.2 version of it, and we keep adding features. So just come and have a look to the labs page, and you'll find more about what Neosemantics can do for you, and join us in the community. That's me. Let's get started, because I think we got a little bit of delay, but yeah, happy to answer any questions on that.
So the role of play, what we're going to do, for those of you who are new, for those of you who've been here before, you know the drill. We've got our 2 presenters. So we've got Siddharth Karumanchi, who's going to be going first, and then he's going to be followed by Doulkifli. So we're going to do our 2 talks. So we've got our 2 guests. They're going to be doing their talks. And then at the end, we have our panel discussion. So if you have any questions, drop them in the chat. So we're picking them up both from YouTube Live and on Twitch. So drop the questions there, and we will pick them up at the end when we do our panel conversation. So without further ado, I will hand over to you. Siddharth, over to you.
Okay, so when we look at any organization, if we break down what actually happens, it is essentially about conversing with data. So it can be either between an organization and a user, or an intra-organizational conversation. All of this happens through queries. So if we are able to understand what the user is asking, and if you're able to prepare the data to give a consolidated answer, this brings a great value to the entire ecosystem. So for instance, if a user is interested in a product, or if he's querying about something, so if we understand the intent as well as the context of the queries, we could always answer in a better way. And prepping the data would be central to the entire process. That is, converting a raw information, or raw data, into a qualified, organized data would reveal the hidden information, which would help in the entire, which would help in making better sense of the question, as well as to give what they are seeking. And connecting various data sources, especially the structured, the unstructured, and preparing them in a unified form would help us to query all the data at the same time. So we are a semantic middleware, which are based on semantic technologies, and this particular layer would sit on top of a databases and in between the users or between the querying. So what we do is we build ontologies, which are basically subject matter experts, the domain information codified in form of an ontology where the rules of the concepts, etc., and how these concepts have been put in a particular hierarchy. Then or build knowledge graphs based upon on the data available and connect with these ontologies and reason, or rather infer information on these instances with the help of a reasoner. And this enterprise knowledge graph would be the base on which most of the activity takes place, most of the exciting activity takes place. For instance, a very interesting interplay is between the knowledge graphs and the text mining and NLP. For instance, in order to extract the entities of interest, or rather to not only to extract, but also to disambiguate and to link with the right concepts. Then say, for instance, tagging of the data, what I was trying to imply was document tagging, then enrichment of the data using the semantic structure in the raw text would be a very interesting interplay. And we believe that this interplay would bring a very unique value to the enterprises. And apart from this, we also manage the data and on top of this build semantic as well as semantic search, wherein an NLP question could be understood, as well as not only the exact answer, which they're not only the exact key, not only the answers based on the keywords in this, but also the related semantic things could be found. So that's so for today's talk, we would briefly go through the construction of the knowledge graph, which we are using to explain what we are trying to do. Then show an ontology-based inference, and also demonstrate the dynamic nature of data, in a sense that when any particular data attributes change, how would the inference change? And finally, we would show an application which is powered by the electoral knowledge graph in order to show how connected data can be represented so that it could be navigated as well as could be interpreted easily. So for the sake of this demonstration, we will be sticking to a knowledge graph which we construct based on the Indian electoral context. So this is the basic outline of how we were constructing this knowledge graph. So the electoral data comes from various sources, like you have the electoral information, that is the real elections that happen, the parties contesting, the candidates, then the parliamentary constituencies from which they contest. And not only this, but we are also integrating this kind of data with the demographic data, which is usually comes from the census, and also the GIS data. So combining all these GIS, all these various sources of data, and defining a graph scheme based on it, we store it in form of a label property graph. The reason being, the label property graph is quite useful for us in exploring the algorithms, as well as because we rely on the attributes of the relations, which is the central to the label property graph method. Now, in order to generate the knowledge graph, we built a custom ontology based on the electoral concepts. So the Indian electoral concepts have been codified, and they first have been identified and they've been codified in terms of an ontology, wherein the relationship between various concepts as well as the hierarchical structure is present. So once we link this instance data present in the label property graph with the ontology, that is when we generate a knowledge graph. So let me first give you a glimpse of the ontology which we have constructed. So this is the, for instance, if you look at a concept like a parliamentary constituency, this is a subclass of the electoral divisions, which are the subclass of a generic divisions. So the way we can divide India is through either an administrative divisions or the electoral divisions, of which parliamentary constituencies are there. So in a way we have, and furthermore, we have linked these concepts to the schema, to the as well as the DBpedia concept. So in a sense that we have our ontology in a way where we are not only putting or not only assembling our concepts in a hierarchical order, but also relating them to the existing known concepts. Okay, so this is just a glimpse of it. It's better to have a look at in the Neo4j. So we have, oh, yeah. So we start off with, this is the, we just written a query where we have got the thing which you're interested in is a constituency. So the Hyderabad constituency, if you look at here, it has a lot of data. So this is so we have the electoral data, which is the name of the constituency, the kind of settlement, it's an urban constituency, the literacy rate, which comes from a demographic data, then it's geolocation, which comes from the GIS data, the polygon of it, everything else has been stored. So we are storing, for instance, the information regarding the regarding this particular constituency in terms of even in the relationship. That is precisely why we felt that the label property graph would be ideal for us. For instance, if you look here, the number of electors who have contested in that particular year, the percentage turnout, etc. So all this information has been stored in form of a label property graph. Now we have actually exported it, then then we have imported the ontology, and then we have linked it. So this is it's a time-consuming process. So for the sake of the demo, we are just going to show the the kind of linking we have done using the namespace matching. So for instance, if I call this, these are all the set of the prefixes which we have loaded, and all of this importing of the RDF data and the ontology is done using the Neosemantics package. So the Harbor Politica concepts are, this is a namespace. So in order to identify the specific elements, we also need to map. So all the mappings, oh, sorry. All the list of the mappings has been added here. So essentially the concepts. So this is the element in the ontology with, and this has been identified with the attribute which is used in the Neo4j graph. So far so now we are also going to show you how the linked data. Oh, I'm sorry, just a second. Just a second, sorry. Yeah. So, and the configuration which we have used in order to the configuration which we have used in order to Yeah, in order to load the ontologies has been this. We prefer the node types instead of the labels because based on the URIs, the linking naturally happens in this setting. So yeah. Okay. Now, in order to see whether the particular parliamentary constituency has been identified with this particular with the ontology, let's have a look. So now what has actually happened is once we loaded the ontology in the particular configuration which we have shown, it is the constituency Hyderabad has two labels. That is, it's a parliamentary constituency and it belongs to election universe. And these two labels have been identified with the concepts in the ontology. And this is, we are storing these kind of labels which exists in the Neo4j as a primary type of the, we are storing it as an attribute, primary. So this is a primary type of the instance identification which we have done. Okay. Okay. Now, if we look at the ontology here, there are other concepts which are based on. So, for instance, if I look at a concept like a Muslim majority constituency, a Muslim majority constituency is defined as a parliamentary constituency which has a dominant religion which with a particular value M. Now, this kind of inference is not there at this moment in our in this graph at this moment. So now we are just for this particular thing, what we have done is we have exported this entire RDF, sent it to the so for this particular thing, we have exported this entire node in terms of an RDF using the Neosemantics package, sent it to an Apache Jana, wherein we have loaded the ontology and used an OWL reasoner to infer all the inferences which we will be using. We get the output in terms of an inferred, the inferred data in form of an RDF. And now we are going to load it back into we are going to enrich our knowledge graph back using the Neosemantics. Okay. So these many triples have been loaded. So this is just for this particular constituency. I have added the all other inferences. So for instance, if I repeat the same query and check, now you see that a lot of other concepts have been identified. That it's a type of the region. It's a general constituency. Now it's a Muslim majority constituency. The reason for that is if you look at the if you look at the Hyderabad, okay. So in order to do this, what we after importing, we are getting a copy of which. So we need to merge these nodes with the existing nodes, with the existing concept called the Hyderabad. And the merging is happening here. I'll just repeat it after this particular thing so that it will become clear. Okay. Okay. So what has, if you really look here, yeah. So yeah, this is it. So here it has been a type of the electoral universe. It's a part of the parliamentary concept which was existing. These also had the primary relationship as true. Now, the other inferences, like it is a Muslim majority constituency, it is a general constituency, it is an urban constituency. These are the inferred type of relations which are added. So just to recap the procedure, so what was happening is we had a particular node. Now we are exporting this through the Neosemantics package. Now, apart from the primary relations which we have established, we are now using Jena to infer based on the ontology. And this inferred data, which is stored as an RDF, is again imported back into the knowledge graph. And the way we do it is once it is inferred, an instance of it is created, and then we are merging with the existing Hyderabad node, and then with all the relations and the properties, and the final inferred knowledge graph is created. So after this, now as the nature of data is dynamic, if we update any particular attribute, we would like to automatically update the inferences. So in order to, so if we just go through the procedure, so what actually happens is, in this, once an attribute is updated, a trigger is fired. So a data is exported as an RDF. Now, again, this has been ingested into the Jena inference engine, and the new inferred data is again coming back and ingested with the same process. So I will just show that by changing one of the attributes here. Yeah. So for instance, here, if you look at Hyderabad, the dominant religion is stored as M, and hence you had a Muslim majority constituency as an inferred data. Okay. Now I am changing the dominant religion to the Hindu majority. Now, yeah. Now, if you look at this particular, yeah, if I look at this particular thing, yeah. Now, if you look at here, oh, it's actually taking a bit of time. So meanwhile, I'll just so this happens through the we also employ the epoch procedure, wherein the trigger happens. So for instance, in the intermediary thing, we have something called to be inferred. So this, I mean, the part of the procedure we have written, it is to be inferred. Like this Hyderabad constituency, this particular information has to be inferred, because here, if you see, we have changed this thing to this. Now this to be inferred node has been created, and now this particular RDF would be sent to the endpoint of Jena, from where the inference takes place. The new inference should be the one with the Hindu majority constituency, and now it should be merged back, and this information should be stored in our knowledge graph. So let me see if it is done. Yep. So now if you look at Hyderabad, now it's been identified as a type of a Hindu majority constituency. If I can show you here. Yes. And the other inferences are remaining the same, because we have not changed that particular value. We have not changed that particular thing. So what we are essentially doing is, we are having a pipeline in which any change in data, any dynamic change in data, especially on the inferred nodes, is immediately identified. A trigger it triggers a procedure. It exports the RDF. Now the RDF which has been exported is being sent to an inference engine. An inference engine is based on the ontology as well as this particular input. The inferred data is being sent as an RDF, and we are loading it back into the knowledge graph using the Neosemantics package. Okay. So yes. So on top of this, so where are we using all this electoral data? The electoral data, especially this electoral knowledge graph, in this ever exploding digital universe, wherein the content is exploding. So especially in this so-called the post-truth world, where the battling disinformation is one of the important things, as well as how do we navigate news or stories across time and space. So because of, I mean, how are each stories connected to another? So in order to look at this, in order to come up with a solution, the best way we feel is to leverage the power of connected data, which we think would help to solve the previous mentioned problems. So this is a basic the flow over which the application, which we call it as Vachan, is built on. So we have, again, various source of data. So we have our electoral knowledge graphs. Then we also have, so these entities of our interest, let's say the politicians, they keep on occurring in various Twitter feeds. They occur in various newspapers, in articles, in the Lok Sabha debates, or in the parliamentary debates, etc. So all this information can be processed using the natural language processing techniques, and that information can be stored into the graph, into the knowledge graph. Similarly, we can also perform traditional machine learning tasks like classification of the text, identifying the sentiment in the text, and more importantly, to generate a vector based on the content in order to perform numerical algorithms on them. So apart from this, we also use some of the graph data science libraries, community detection methods, centrality of these nodes, and similarities. And all of this is on the base of the knowledge graph. So the knowledge graph, it has our domain knowledge graph, the knowledge base, along with the community knowledge base, let's say Wikipedia. All this information can be put into one particular source, and that is what is powering the application called Vachan, which would help us to navigate through connected data in a seamless way. So just to recap again, so we have our the electoral knowledge graph, then various sources of data like the GIS, demographic, the electoral data. We built a custom ontology, and there is a community knowledge graph. All of this would be the base on which the NLP processing takes place. For instance, identifying the entity in question and correctly identifying, in fact, disambiguating it from the other things based on the context, and then linking it with the existing nodes in the graph. All of this is powered by the knowledge graph and the text mining processes. So let me just quickly show the application. Yes, Vachan. So this is how the loading page looks like. So basically, each bubble is a story. So for now, each bubble is a story, and this is about like 40 stories which are important. So the importance of the stories has been evaluated according to the importance index, which is based on the trending data. Like, for instance, if any particular entities are trending, let's say COVID is a very interesting topic right now. So based on the trending, as well as based on the importance of the stories in the network itself, as well as the content, of course, and also based on the topics or on the genre of the stories. So all these stories, the important stories, have been displayed, and if I look at it, so what happens is the stories have been tagged, the entities have been extracted, and they have been linked to the correct to the thing, as well as we also give the genre of the story, which is it's a world news. Now, if we click on this particular entity, we go to the entity page. So in essence, every entity, so every atomic concept inside the story. So instead of searching for keywords or instead of searching for topics, we think that entity-based searching, as well as once we consider entities as the atomic units of this, everything else becomes quite seamless. The relations between them becomes more explicit, and the navigation through how these particular things happening would be interesting. So so this would be a microsite for this person, Narendra Modi, who is, and here we display all the articles or the stories which Narendra Modi is featured in. And here you have the people who, the entities which are related to this. So Manmohan Singh happens to be the ex-Prime Minister of India, and these are the genres which are being displayed over here. So apart from this, we also have, ours is built on top of electoral domain knowledge. So we have all the information regarding the candidate of interest, and the other political information, which we are planning to put it in form of a data art, which can be consumed, as well as which can be which would not be a boring way to explore data, especially when you have so many important and diverse electoral concepts. So I think I will just quickly go through the kind of like one of the algorithms which we used, which features centrally in most of the tasks we are doing, is a community detection. So though it would not be fair to give a demonstration in such a short period of time, I will just go through the methodology in which we have identified them. So for instance, if we are looking at two particular entities of interest, let's say two entities of interest, and in our graph they are connected via other relations. So let's say this is the type relation based on the concepts we get from the ontology imported. So what we do is, because these are multi-partite graph and a multi-label graph, now the graph algorithms in the Neo4j are supported only on a monopartite graph. So we project this graph into the based on these relations onto the space of entities and entities. Then we perform a centrality measure. Now, this is not the only one kind of projection which can happen based, but we can do other kinds of projection, say based on different other kinds of relations between these two entities. Finally, what we get is we get vectors of these features, these network-based features, which we store them and scale them, because the measures might be very different for in order to make it much more robust. We scale them, and now we compute a similarity graph based on these entities, based on the vectors. And now once we have a similarity graph, we do a community detection, and this community detection can be used as a seed in order to improve again once we iterate the process. I think so what we are currently still continuing to do is to build a full-fledged semantic search on top of the layers which we are developing. Then we would really like to start exploring the knowledge graph embeddings. So for instance, Neo4j currently supports, recently started supporting the vectorization. So we can embed these graph-based nodes into a low-dimensional space. But unfortunately, again, these are restricted to a monopartite graph. But if we want to consider the full scale of the semantic space, as well as the relationship space and the node space, we would like to explore the knowledge graph-based embeddings in order to carry out the further algorithms and try to see how much of a difference this would make. And finally, we would also like to implement the shackle validations in order to standardize our graph to the W3 standards. Yep. Yeah. I think, we are open to discussions for proof of concepts in the domain of healthcare, finance, banking, media, and governance. And this is our website, and this is our Twitter handle. And I think I'm good to take questions. And I would like, once again, thanks Neo4j for giving this opportunity.
Yeah, thank you very much, Lou. Thank you. Thanks for the presentation. It was really interesting, and it's good to see Neosemantics in action in a real project like yours. I think I have some more specific questions on especially the inferencing iteration that you run. But first, I wanted to ask you if you could maybe elaborate a little bit in the type of use cases that you work with, because you mentioned briefly at the end, I mean, we're open to projects in healthcare, finance, government. Maybe you can give us just a high-level idea of the kind of situations where you find your platform being used or adding special value. And so, does that make sense?
Oh, yeah. So at the moment, we have developed it using the electoral data to the full-fledged. So, for instance, if we are looking at these non-trivial inferences which we're getting it, and also the kind of which would help us to look at the sources of information. For instance, if you look at the politician and his interactions with various parties, various businesses, then the sources of money into politics. These are the places where we have actually looked into it, and we have made small cases of let's say financial setting and clinical text data. Though we are not yet, it's not at the proof of concept level, but we do have some use cases with extracting information from raw clinical text to a qualified data. And then we would like to use that, in that process, we would like to use these inferences, for instance. Then even in the financial sector, of course, the fraud is a very ubiquitous use case for such kind of a scenario. And we would like to power our semantic search based on this inferences.
That's right. Yeah, great. That makes sense. Yeah, and I guess it's this kind of investigative kind of type of use cases, similar to the kind of, for example, the Panama Papers that we've been talking for many years now. And I guess that's where the inferences can add value, enriching your graph and deriving new information. So you've mentioned that we've seen how you create your ontology and then you bring it into Neo4j.
Yes.
So and you're using kind of web standards, and you've mentioned OWL. Is that the kind of constructs that you use? I mean,
exactly. Yes.
Okay, and
Yes. We we built the custom ontology which we built. We integrated with the DBpedia ontology as well, which we founded in an OWL form. So we built it on top of that so that the common concepts could be easily identified as well.
Right. Yeah, that's great. So I was thinking, because one of the and this is where I go a bit deeper into the way you're using Neosemantics, because I see there's this loop where you build your knowledge graph in Neo, but then at some point you have to export it into the Jena OWL engine, and then you run the inference, and then you bring back the results. So one area where the Neosemantics project is going is in space of developing more of these inferencing capabilities, and one of them is bringing I don't know if OWL or maybe OWLDL or RDFS, some part of it, but bring some of these inferencing into, I mean, as part of Neosemantics, and therefore something that you can run in Neo4j. Is that something, because I see that this would potentially simplify your architecture, right? If you could run this inference
exactly
without having to kind of have the data transit outside and then input, that I think that would be an improvement. Do you see that?
That would be a huge advantage for us if we could, because as far as we checked, there were only hierarchical inferences in Neosemantics, the simple hierarchical inferences, and now we are making inferences based on the node properties. And furthermore, I mean, though we have not displayed, we want to do it based on the relationships, further relationships as well. So for these kind of things, we were forced to move out of the Neo4j framework and go to Jenna and come back.
Yeah, and that's interesting because, as you know, the inferencing can be powerful and it's quite rich, but it's also in a way a can of worms sometimes, because you can get into situations where it either takes too long, it's too heavy process when you're working on large volumes. So we've intentionally been a bit cautious in that area and just adding small bits of inferencing capabilities. But it looks like that's an area where there's definitely interest. So we might be So I would say watch this space, because we will be working on that front. So
absolutely.
Well, I mean, Liu, I could go on. I don't know if you probably want to ask something, or shall I? I mean, I'm happy to continue, but
unexpected in a sense that we at least the explainability has been improved greater deal. Like let me be cautious and say that, for instance, the role of certain the money in certain in the Indian electoral system, it has been much more clearer now. Like what are the main sources, the builders, or these kind of concepts which was always like part of the hypothesis. But yes, we found concrete understanding based on this. So it's like the explainability has been improved a greater deal. But to your question, if we did find some unexpected results, no, not yet.
I think Liu's question is in the direction: are we going to have another Panama Papers in the Indian news soon, and another case of investigative journalism?
Unfortunately, we are only going to the digital content, which has been the last 10 years. So yeah, I see the point. Yeah. No, not even the funky stuff, but yeah. So the label property graph, which we originally designed, was the intention was to run some algorithms as well as to do a lot of aggregate information, etc. and all. So, but when we were exporting for exporting it in the RDF form, we just did it for the nodes because we knew that we were going to infer only based on the nodes. So, and we linked all the nodes with the ontologies. So we have in a way preserved the structure of the label property graph and impose this linking with the ontology on the nodes, and then create we're inferring based on the use cases. Let me put it this way again. So we have created a label property graph based on the kind of aggregations and the kind of queries which we are interested in general. And then when for the inferencing, what we have done is we have just exported the nodes, just the nodes and their attributes in an RDF form. And then when we are inputting back into this, we are just linking those elements with an ontology which we have created for this purpose. So essentially, the label property graph structure is still intact.
One quick question, just to add, just to get an understanding, because mostly I guess we're talking to developers here. So it might be good if you could give us a little bit of an overview of the stack. I mean that you've been using, because there's Neo on one side, there's Jenna on the other side. I mean, is the whole this loop, is it? And you've mentioned you're using triggers to, but is this loop automated? I mean, are you using probably Java since you're
yes,
Jenna?
It's based on Java. The Jenna is based on Java. Yes. And the Spring framework for the ingestion and the everything else.
Right. So you have a process that basically does the import of the data out of Neo, brings it into Jena, runs the inference, and then brings it back. And that's basically Java and SDN, right?
Yes.
Good. Yeah. No, that's useful. Thank you. Yeah, that's me. I mean, I could probably take offline the rest of the conversations because I'm interested in how the whole, how you've implemented the importing of the results of the inferencing, because I like this idea of flagging, the primary types and the derived types, because I guess then you have to be able to retract some of the derived facts when the environment change, and that's an interesting thing to keep in mind. But yes, that's probably. I mean, I think I'm good with questions. Thank you very much for your presentation. Really interesting, and looking forward to hearing where you.
Certainly. We can definitely connect offline. We would be extremely happy to discuss further and try to streamline the processes if we can find any other, Neo4j tricks.
See you. Bye.
Thank you. Bye-bye.
Bye.